The auroras, commonly known as the northern lights, Aurora Borealis, or the southern lights, Aurora Australis, are one of nature's most spectacular phenomena. Witnessed in the high latitude regions around the Arctic and Antarctic, these dazzling light shows result from a complex series of events involving the Earth's atmosphere and magnetic field, as well as solar activity. Originating from the sun, solar wind, and CMEs. The story of auroras begins with the sun. The sun is continuously spewing out a stream of charged particles known as the solar wind, a flow of ions and electrons escaping the sun's intense heat and energy. Occasionally, the sun also releases giant clouds of magnetic plasma in what are known as coronal mass ejections, CMEs, which can greatly intensify the solar wind. The Earth's magnetic field, a protective shield. When these particles reach the Earth, traveling at speeds of up to several million miles per hour, they are met by the Earth's magnetosphere, the region dominated by the Earth's magnetic field. This field extends thousands of miles into space and acts as a shield against the solar wind. Magnetic interactions, guiding the particles. As the charged particles from the solar wind interact with the edge of the Earth's magnetic field, some are trapped and funneled along magnetic field lines toward the magnetic poles. As they converge towards the poles, the particles spiral down along the field lines. Atmospheric collision. The light show begins. When these high-energy particles finally collide with the Earth's atmosphere, around 80 to 300 kilometers above the surface, they excite the atoms and molecules of gases such as oxygen and nitrogen. When the excited atoms return to their original energy state, they release photons, the basic units of light. The color of the aurora depends on the type of gas molecule and the altitude of the collision. Oxygen can produce either a greenish yellow or a red light, while nitrogen generally gives off blue. The green aurora is most commonly seen because the human eye is more sensitive to green wavelengths and because these interactions frequently occur at altitudes where oxygen is abundant. Varying displays, the dance of the lights. Auroras can display an array of shapes, movements, and colors. They may appear as static glows, shifting curtains, or shooting rays that light up the night sky, depending on the amount of solar activity and the interacting atmospheric conditions. Statistical significance. The intensity and frequency of auroras are heavily influenced by an 11-year solar cycle, where solar activity increases and decreases over this period. The probability of observing an aurora at lower latitudes increases during periods of high solar activity. Data shows that auroral activity is most prominent during the equinox months of March and September. In conclusion, the science behind auroras is rooted in the interaction between the sun's emissions, the Earth's magnetic field, and our atmosphere. This grand cosmic play is not just a stunning visual spectacle, but also a reminder of the dynamic nature of our planet's relationship with the sun and the complex systems that protect and influence life on Earth. While viewing an aurora is often a matter of geographical luck and timing, understanding the processes behind its formation enriches the experience with awe-inspiring knowledge.